So we start our intro to calculus with a bit of review of end behavior. End behavior was the idea that we can model a function's behavior off of the graph at really large and really small values. So we look at this very first polynomial here. As x goes to the left, as we start talking about really large negative numbers, y is going to continue up and up and up and up forever. So as x gets really large in a negative way, f of x is going to tend to positive infinity. So we played around with this both in the polynomials unit as well as with rational functions. The opposite happens on the right-hand side of this function. If I kill this arrow and that arrow, as x gets really large, now we're talking about the right-hand side of this graph. So now as x goes to positive infinity, the function is going to head downwards towards negative infinity. We had a big table for this in the polynomials unit where you could just look at the exponent and the lead coefficient to determine that end behavior. Rational functions could be a bit more interesting because they could have horizontal asymptotes. So you could look at something like number 2 here, and now my left behavior is no longer y going off to infinity, but rather now is x. As x goes to the left, as x is going to negative infinity, that function approaches a number. We can see that arrow there approaching the value 1. On the right-hand side, we wind up with the same thing, only now x is approaching positive infinity. It's going to the right, further and further and further, and our arrow should be blue. Our arrow for the function is also tending towards 1. So as x goes to positive infinity, the function approaches 1 as well. In general, this concept is called a limit. As x approaches some value or infinity, the value that our y or our f of x approaches is just called a limit. We've played with this before. The notation is a bit wonky, but to describe a limit, we say that the limit, LIM, as x approaches a value, and we're going to use c for that for now. As x approaches some value c, or possibly infinity or negative infinity, then the function is going to approach a limit. And we usually use L to talk about that limit. So L can be a number, like it was in this right example. L can also be something like infinity or negative infinity. So let's look at a few more end behavior examples before we dive into finding limits without pretty pictures. And we'll just alternate left, right, because there's not a whole lot of space for writing here. So we'll start by looking at a left end behavior. What's going on to this function on the left-hand side? Well, since we're talking about the left side of this function, what we want is the limit as x goes to negative infinity. Again, that negative there is talking about the left side. All of our small values, or really large negative values, if you want to think about it that way. So as x approaches negative infinity, this function is shooting off towards negative infinity on the y-axis. So we just looked at a left end behavior. Let's take a look at a right end behavior. Taking a look at number 4 there, we're talking about that arrow that is shooting up. Since we're talking about right end behavior, this is a limit as x goes to positive infinity. So what's happening to our function as x goes to positive infinity? Well, our function is also heading towards positive infinity. So again, contrasting that with example 3, on the left, this function went down. For number 4, on the right, this function's going up. So we did a left, and then we did a right. Now let's do a left. So we're talking about that chunk of the function now, our left end behavior. So since we're talking about the left, that's the limit as x goes to negative infinity. That's where my negative numbers live. And what's happening to my function? Well, I don't know. That arrow's going up. So that's our positive infinity numbers. Again, if you were putting this in English, on the left side of this graph, y is going up. Let's look at a few that give us numbers. Spoke too soon. Number 6, taking a look at number 6. Since we just did a left, we'll take a look at a right. That arrow is still tending up. So this one isn't quite interesting yet. We'll do an interesting one in a second. So the limit of this function as x goes to positive infinity, talking about the right-hand side of the graph. As x goes to positive infinity, so does y. So that's this arrow highlighted here. Number 7, things do start to get a little bit more interesting. So for number 7, I want to look at both the left and the right end behavior, because it's going to be, there's going to be a number involved here for that right one. We'll start with the left end behavior there, taking a look at the arrow highlighted in yellow. There, since we're talking about left, that's the limit as x goes to negative infinity, because it's on the left side of our graph. That function is going to go to positive infinity. So again, that is for the left arrow. Get a little more room. Get it. The more interesting side is actually on the right here. So as x tends to positive infinity, now we're talking about the right-hand side of this graph. This function is no longer approaching infinity, because we're talking the right-hand side. It's approaching negative 1, 2, 3, 4. So on the right-hand side, it's approaching a value instead of this concept of positive or negative infinity. As we start moving forward, we really want for our limits to be numbers. Then we can do some algebra with them and all kinds of other fun things. But for now, we do have examples where infinity is an option. We'll do the same thing here for number 8. Note that in number 8, both the left and the right approach a value. So on the left-hand side, as x goes to negative infinity, f of x goes to 0. So that was talking about, wrong cone, this side. And then on the right-hand side, now we're talking about x going to positive infinity. The function still tends towards 0. So here we have a case where both the left and the right end behavior are the same. Number 8's an interesting function because the end behavior really isn't where it's interesting. Where it's really interesting is right here in the middle. So we're going to need a slight shift in notation to play around with that. But this video has been long enough as it is, so we'll put that in the next one. See you soon.